Continue on with your topic 5. So in sanitary and sewerage, flow rate is very important. So flow rate is represented by Q, and then the unit is meter cube per second. So if you were to convert meter cube per second, then you want to convert it from liter per second to meter cube per second. So you need to just divide it by 1000 lah. So but to convert it into this, you have to multiply it by 1000 lah. So this is just a different conversion of unit. So liter to meter cube. So you multiply it by 1000 for 1 liter, you get 1 meter cube. And vice versa, if you have 1 liter per second and you want to convert it into meter cube, so you have to divide it by 1000. So flow rate is the volume of water flowing per second. So whenever you deal with anything that flow, usually you will say that this is water. Even if it's wastewater, it's still water. So water is in meter cube per second. So to get this meter cube, you have your volume, which is in meter cube, and you have to divide it with time. So this is the most basic of how a flow rate is. Okay, so next we have our Q equals to VA. So this is the most fundamental formula which you have to remember. You don't have to remember because you'll be given the formula list in which the appendix will be made available to you with all this formula. But wherever you go, if you were to encounter any flowing water, this will always be that Q equals to VA, where Q is the flow rate, with V is your velocity multiplied by the cross section of the pipe. So to find a flow rate of a pipe, you have to just multiply the flow velocity of the pipe, water flowing in the pipe, and also the cross section area of the pipe. This way you will get your flow rate. So Q is represented by these two formula but usually the important formula is this. So this is just for your info on how this flow rate is obtained. Is from the volume divided by the time taken to pass through a point. So usually in a question, you'll be given the flow rate and also the cross-section area to find out the Q. So you won't be, if you were to be given the volume and the time, you also can use it to find the Q But this is the most important formula. So if you go to other subject and it deals with water, always remember that Q is equals to VA, where V is the velocity and A is the area of the pipe. So in this subject, you will only be dealing with Chassis formula which is represented by this. So the flow in the pipe can be calculated using Chassis formula. So V equals to C, which can be a constant, 55 if it's given to you, square root mi. So I is the inclination of the fall, means how steep the pipe is from point A to point B, and then m is the hydraulic depth. So hydraulic depth is the is equals to cross section area of flow divided by length of wetted perimeter. So m is equals to cross section area of flow divided by length of wetted perimeter. So in a full pipe, the wetted perimeter is all around, and in a half pipe, the wetted perimeter is just half. And then for the cross section area of flow, it means when the water is full, this is your whole area, and when the water is only half, you you only have half a circle. So in this case, with this sort of scenario and with the formula of how to find this area and also the length of this method parameter, you can go and calculate it out lah, for either half or full, for full or half. In the case of a round pipe, you can always assume M is equals to D over 4. So in a full bore, you use area of flow divided by this method parameter. And in a half full pipe, you can use area of flow here divided by half length of this method parameter, which is this. So if you were to calculate it out, this divided by this and this divided by this is actually the same, because this is full, where both the parameter is full, and then here this parameter is only half with the area is only half. So you only in the case for the round pipe, your M will be a constant of D equals to 4, based on the derivation of these two formula lah, where you divide these two, it will be the same, because the situation is still similar. You get D over 4. So remember this lah. Okay, so next is inclination. So hydraulic gradient. So your pipe will always move from high to low via gravity. And then for your Chegis constant, if you are not given a value, which is in this case 55, you can actually find out what is Chegis constant through this formula, which will also be available in your appendix lah. So C is equals to the square root of 2G divided by F. Okay, so for this part, 2G is acceleration due to gravity. So acceleration due to gravity is always a constant lah, is 9.81. And for F, coefficient of friction, this will actually be given to you either 0.0064 or as the question stated. So in a normal question, if it's not mentioned, usually F will have to be mentioned for you to find the Chegis constant, or the question itself will give you the value for your this Chegis constant, which is 55. So this 55 is obtained through a coefficient friction of 0.0064. So you get a C equals to 55 based on this formula. Okay, so inclination of 4 is the depth of your pipe lah, from high end for one end to another end. So usually there will be a inclination of 1 to 300. So you have 1 meter, and then you have a length of for depth of 300 meter. So the less value of this, the steeper the pipe is. So let's say you have a 1 meter to 1. So the drop of 1 meter will have only a length of 1 meter. So it will be a very steep pipe here. So in a case where you want to have a very less steep pipe, so you want to have a higher value here. But depending on the question, if the question is asking you to, is a question have a requirement of, let's say, 270 requirement, you want to recommend a steeper pipe, so you have to go lower. The value has to be lower. So if you obtain a requirement of 270 gradient of inclination, then you have to recommend 1 is to 250. So you will get a steeper pipe than the requirement if it's asking you to recommend lah. So this will be what you'll find in your tutorial lah when you do it. Okay, so into the example, you have your first example, which is to find the discharge capacity. Using the Chegis formula, you have to find the Q of a 200 mm diameter sewer pipe. So you're given the I is equals to 1:200, and you're given C is a constant of 55. So using the chassis formula, which is this, V equals to 55, which is a constant, divided by the multiply by the M. So you remember back in this slide, M is equals to D over 4. So this is the case only when your pipe is a round pipe. So if the pipe is not a round pipe, let's say a square pipe, which is unlikely lah, I will give it to you. You have to use this M formula. So this constant M, D over 4, is obtained from this M equals to cross-section area of flow divided by length of wetted perimeter. So this is already simplified lah. M equals to D, which is the diameter, divided by 4. So it's a simplified from the full bore and a half bore from the formula to this. So in the case of a round pipe, you can always assume that your hydraulic mean depth is D over 4. So coming back to your example with D over 4, so you substitute your D with your diameter of the sewer pipe. So the D will be in meter. So you have 0.2 divided by 4, and you have to divide by the inclination. So your inclination is giving you 1/200. So you have 0.2 divided by 4 multiplied by 1/200. You'll get your V equals to 0.86 meter per second. So given using Chegis formula, you're able to find the velocity. So you need to use the discharge formula to find the Q. So you know that now you obtain your V. Next, you want to find what is your Q using the Q equals to VA. So you know what is A, which is in this question, you're given a pipe in full, flowing full, means it's a full bore. So the area for your pipe is just a pi r square lah, or either that you can use this pi over 4 d square, which is the same thing lah. So in this place, I'm using pi r square. So pi r square multiplied by the velocity, you'll get the Q. So given that 1 liter is equals to, given that 1 meter cube is equals to 1000 liter, so you can convert it into liter per second lah, using this method. Using this unique conversion rate. So if the question didn't ask to convert the meter cube to liter, so if you end the question here, it will be good enough lah. But if the question is to ask you to convert it into liter per second, then you have to use the conversion rate to convert it lah. So this is just a conversion rate. Okay, so question 2, still the same. So question 2 is asking you to suggest the size of the circular sewer pipe to be able to discharge 20 liter per second. So now you're given this 20 liter per second instead of meter cube. So you have to convert it into meter cube per second lah. So with the formula still the same. You're given chassis. You're using chassis formula, and also Q equals to VA. And with that, you have to equate it together lah to get your D, because you are not given the diameter. You're given the discharge. So here you put in your you equate it together. You substitute your V into here, and you'll get this formula. And you know your M which is d over 4. You can substitute the m with your d over 4. Then you have a big variable lah, a big equation for you to sub all the known variable into this equation that you have made. And with that, you will have to move your formula around lah and solve it on one side. So finally, you will get that D is equals to 0.177 meter. So you have to provide 200 mm pipe size diameter. So for the pipe, you have to round it up, and then when you are doing the inclination for your tutorial, you will have to round it down lah. Okay, so because of how the pipe is being laid, so 1 to 1, it will be a very steep pipe. 1 to 300, as a value increase here, the pipe will be less steep and you'll be a longer pipe. Okay, so this is only the calculation part lah. This is the only calculation part for your topic 5. You only have to make use of this formula. Q equals to V multiplied by A, and then V equals to C square root MI. So you're using Cheggy's formula, and Q equals to VA. Okay, so you have any question?